Welcome back, everybody. We're on lesson number 4, coordinate geometry. And specifically, we're going to be talking about parallel and perpendicular lines here. So, let's look at what we need to know about them. Parallel lines are lines that have equal slopes. So it doesn't matter what that slope happens to be, it's going to be the exact same thing. Perpendicular lines have opposite reciprocal slopes. So, in this particular situation, we would have to have opposite signs, one positive, one negative, and the reciprocal. So we see an example here of 2 over 3. The reciprocal here would be 3 over 2. Okay, we flipped. So we would say opposite signs, and then flipped is what we would usually refer reciprocal to in class. Okay, and it mentions slope for both of these. So if they tell us what our slope is, like it is given here, we just have to think about these rules. If they don't give us the slopes and we have to calculate it, we know how to do this. We've seen this formula before. We know our slope inside of the y-intercept formula is m, so we're looking at m as y2 minus y1 over x2 minus x1. Rise over run. You've seen and heard all these things a whole bunch before. So anyways, when we look at this example that talks about slope, and we want to know the parallel and perpendiculars. So here, for parallel, we want the exact same slope. So it says 2 over 3. We want 2 over 3 for a parallel slope. Perpendicular, however, we need the opposite sign. So right here, this would be positive, so we want this to be negative. And the reciprocal, or flipped, so 3 over 2. Okay, pretty simple. Here, they give us a slope of -4. If we want a line that's parallel, this would be the exact same, so -4. Perpendicular. Well, what I'm going to do real quick is put a 1 underneath my original slope. That way I know when I have to do the flipped fraction part, the reciprocal, I want to flip that fraction upside down, which is 1 over 4. As far as positive, negative, this is negative, so I want the opposite, so this should stay positive. I'm not going to have any negative sign there. Okay, I want you to try. You can pause the video and resume it when you're ready to check these 3 here. Alright, let's check them out. Slope here is -5 over 2. So if we want parallel, we're going to use the signs, right, the little symbols, parallel. It should be the same, -5 over 2. If we want perpendicular, we want the opposite sign, so it would become positive, and then reciprocal or flip fraction, 2 over 5. For B, I'm going to quickly put this over 1. So for parallel, it's going to be exact same. So we'll keep that as just 3. Perpendicular, well, this has got to flip, so 1 over 3 now, and then opposite sign would make this become negative. And then last, we've got the exact same, so 1 over 9. And then here, if we flip this, that becomes 9 over 1, so just plain old 9. Opposite sign would be negative. If you had this over 1, okay, same thing. Alright, let's check out some other problems that we can do with coordinate geometry. Some real basic parallel perpendicular coordinate geometry anyways. We want to find the parallel and perpendicular slopes to AB if we're given some particular coordinates. So what does that mean? We got to figure out the slope of AB, and then we're just going to find one that's parallel and one that's perpendicular. As soon as we get the slope of AB, we automatically get parallel because they have to be equal. Once we get slope of AB, we have to flip it upside down. That's the reciprocal, and then change the sign, and that'll give us perpendicular. So we get one pretty quick, the other one a little bit of extra work. Anyways, Take a second and label them out if you need to. We'll find our slope of AB. So we want y2 minus y1 over x2 minus x1. Here, that gives us -4. Double negative becomes addition. So that's -4 over 5. So, for parallel, has to be the same. For perpendicular, needs to be flipped, which is the reciprocal, and then opposite sign, so negative, keep this one positive. Here's one for you to try. Okay, pause the video and resume when you're ready to check this one out. Alright, let's see. Excuse me. First, we want to find the slope of PQ. So we'll subtract y2 minus y1 over x2 minus x1. -4 over -6. Those are going to cancel out. And then that leaves us with, let's see, 2 over 3. I still have this here to keep track of in case this shows up over here. When I, never mind. Just ignore that. Nope, I'm reducing this. So I got rid of this. I'm reducing this. Okay, we got 2 over 3. So we want parallel. 2 over 3. Perpendicular, if we want perpendicular, we flip it, change the sign. So -3 over 2. Sorry about that. I don't know what I was talking about. Glitch in the brain, I guess. Alright. A couple more problems to take a look at. Here we're going to determine if A and B are parallel, perpendicular, or neither to PQ. Alright, so let's think about what needs to be done here. We need to compare their slopes. So we need to find the slope of AB and of PQ, and then we'll compare them. If they're parallel, they would have to be equal to each other, so they have to be the same. If they're perpendicular, they would have to have opposite signs and flipped fractions, right? Opposite reciprocal. If it's neither of those two things, then they're neither parallel or perpendicular. So, first thing to do, find their slopes. So, AB's slope we'll do first. So let's see, we want y2 minus y1 over x2 minus x1. That gives us 4 over 10. Alright, this is what I was saying that I cut myself short earlier. I'm going to leave this as 4 over 10 here. I'm still going to reduce it to 2 over 5. But I can keep this in mind. If I happen to see the 4 over 10 show up when I find PQ, then I pretty much know I have it. So I'm going to keep this in mind. But we always want to reduce anyways. But here's the slope of AB is 2 over 5. So now what we want to do is find the slope of PQ and then compare them. So we've got 6 minus 1. We've got 0 minus 2. This is 5. And this is -2. So now let's compare them. 2 over 5 and -5 over 2. Alright, so we found the slopes. We compare them. One of these is positive, one's negative. So it's definitely not parallel, so they would have to be the same. And if they want to be perpendicular, they have to be flipped in opposite signs. So 2 over 5, 5 over 2, those are differently flipped. So this is perpendicular. That's it. Okay, you find the two slopes and you compare. Take a look at this problem. We're doing the exact same thing here. Okay, determine if they're parallel, perpendicular, or neither. So we've got to first find those slopes. So for AB, let's see, we want 7 minus -2 and -2 minus -5. That's 9 over 3, which is 3 over 1, or we can just call it plain old 3. 3 over 1 I'm going to keep just because it's easier to compare. PQ. Five minus -3, 2 minus 0. Let's see, that becomes 8 over 2, which is 4 over 1. Alright, so we've got 3 over 1 versus 4 over 1. If they're parallel, they have to be exact same, which they clearly are not. Perpendicular, they would have to have opposite signs, which they don't. They would also have to be flipped. Doesn't matter. So these are neither. These are neither to each other. If we were to look at a graph of this, real quick, visual, right? -5, -2 is here, and -2, 7 is way up here. So this is this line. And then 0, -3 is about here, 2, 5. Alright, so I missed the point a little bit here, but here's the deal. This thing is going a little bit more steep than this thing. It's just a little bit steeper. So eventually they'll cross down here, making them not parallel. Alright. We got 2 of these for you to try. They're the exact same problems that we were just looking at. Okay, you're going to determine if it's parallel, perpendicular, or neither. And there's another one right down here. In fact, I'm going to try to see if I can get them both in. Pause the video and try both of these problems out, and we'll check them both out right after. Alright. So hopefully you did both of these. We're going to do this one first. I'm going to do AB first. So we've got 6 minus -2 over 4 minus -2. Double negatives all over the place here. So 8 over 6, which will reduce to 4 over 3. And then we've got, let's see, oops. For PQ, 0 minus 6, 4 minus -4, so let's see, -6 over 8. Oh, look, see, 8s and 6s, positive versus negative. So I can already see from here that these are perpendicular. We can continue to reduce. We can still see it with those finalized numbers, but it's same thing. Okay. The other one that we had to try out was AB. First PQ. Here are the coordinates. Oops. For AB, 4, 3, and -3, 1. So let's find that slope. -2 over -7, so 2 over 7. And then PQ. By the way, I've been doing this throughout the whole thing, right? Quick take a second to label them right before you plug them into your formula. You don't get the wrong thing in the wrong place. So let's see, that's 2 and then 7. So we get 2 over 7 versus 2 over 7. Those are the exact same thing. That's parallel. Done. That's it. Nothing else to see here, folks. Lesson number 5 coming up is applications of this on quadrilaterals. So, see you there. Bye.